Let's have a look at parabola. Parabola is a function given by this function. Common one is that. Now, there are steps that you need to follow when you intend to draw a parabola. And the first one, you need to show the x-intercept and the y-intercept. And the axis of symmetry. And the turning point. Turning point there. Now, when you look for the x-intercept, you always let y to 0. The same way we let x equal to 0. Now, let's say you are given f of x is equal to x squared minus x minus 6 is the same as your y is equal to x squared minus x minus 6. When you look for the x-intercept, equating y is 0, have x squared minus 6. Now, if you have a trinomial of this nature, you get the first term and the last term. This can be written as x squared minus x exponent 1 minus 6 exponent 0. I hope you realize the pattern here. So, because x to the power 0 is equals to 1, therefore 6x to the power 0 is equals to 6 times 1, which is equal to 6, which is our last term there. So, you get the factors of the first term and the factors of the last term. Here, if I multiply x by x, I will get x squared. If I multiply 3 by 2, I'll definitely get 6, 2 here. Now, this middle term here is negative, so the bigger number must be negative, the smaller number should be positive. So, now what happens here is that when I multiply x by 2, I'll have positive 2x. When I multiply 3 by negative, I'll have negative 3x. And the answer here is minus x. Since are not the same, subtracting some of bigger number. We have that. So it means these are the correct factors. Writing down this way will be X minus 3 multiply x plus 2 is equal to 0. That's what we have here. So x minus 3 is equal to 0, or x plus 2 is equal to 0. If you multiply two numbers, if you multiply a by b, you get 0. It's either a is 0 or it is a b that is 0. Or a and 0 and b are both zeros. That is a 0. That is a 0. So we're taking that the first number here will be equal to 0, and b here will be equal to 0 there. So x will equal to 3, or the x will equal to a negative 2 there. Therefore, the coordinates will be, when x is 3, y is 0. We chose y to be 0 here. We get y equal to 0 when we look for the x-intercept. And the other coordinate will be negative 2 and 0. Now these are called the x-intercept, or we call them the roots, or the zeros, or the x value, or we call them the x-intercept. Or the x-intercept. As we have done there, let's go to the next step. The next step is y intercept, where we let x to be 0. We have y is equal to x squared minus 6 minus that. When x is a 0, that will be a 0. So in a coordinate form, x is 0, y is a minus 6. Now, the first step is the x-intercept, the x-axis, the axis of symmetry. On the axis of symmetry, we let x is equal to negative b over 2a. The function will be symmetrical along this value of x. Now we have y is x squared minus x minus 6, where a is equal to 1, b is negative 1, and c is 6. From the form ax squared plus bx plus c, the coefficient of x squared is our a, so we have 1 here. The coefficient of x is a b, and the number that is independent of x is our c. So our C is -6 there. So we sharpshoot those values there. Therefore, we say axis of symmetry is equal to negative. Our B is going to be -1, 2, and our A is 1. Negative multiplied by negative is positive. 2 times 1 is a 2. So that's what we have. Now the fourth one is for us to get the turning point. Now with the turning point, we substitute because the graph or the function is going to turn along the x-axis. Therefore, we say f of minus b over 2a, which is minus b over 2a. Minus b over 2a was a half. Let's check the previous page. Now that was a half. Minus 1 over 2 minus 6 over 1. I like that those fractions. Half squared is a quarter. Minus 1 over 2 minus 6 over 1. This is 1 over 4 minus here. I'll multiply here by 2, multiply here by 2. I will get 2 over 4. And this can be 24 over 4, which is 6. And that will give us a common denominator. 4 is 1 minus 2 minus 24. And that this is 226 minus 1 is minus 25 over 4. 4 into 25, 6 times 24, remainder 1 over 4. So the turning point coordinate will be x will be a half and y will be -6, 1 over 4. Now you have the coordinates. You can plot the graph, plug in those coordinates onto the graph. Let's draw the Cartesian plane and see what you can get here. On that system of axes, we will have here 1, 2 there, 3 there, 4 here, -1, -2, -3, have 1 here, 2 there, 3 there, -1, -2, -3, -4, -5, -6, -7. Let's go to, this can be 4 here, 5, 6 there. Let's go to our coordinates. Turning point is x here is a half. X here is a half. So the graph is going to turn down. And that's 6.5 somewhere there. 6 and 1 over 4 somewhere there. So the graph is going to tend there. Now, we know that it's passing the y-axis at -6. At -6. There it goes. Let's go and have a look at our x-intercept. Our x-intercept 3 and -2. 3 and -2. So the graph will come this way. Come this way. And there. And from there. Go to infinity. Now, that is your graph. This is your x-intercept. This is the y-intercept. The y-intercept is always given by c, and then this is our turning point where the graph turns. And then we can label that as f of x is equal to x squared minus x minus 6. That is drawing the parabola given the equation or the function in the form of ax squared plus bx plus c. You follow the first 4 steps and plot the graph. Now, this is the minimum. The minimum point that the graph can go. And because your A is positive, the graph is facing up. Had your A been negative, it will face down. It will go face down this way. Now, if it faces down, that will have the maximum. That will have a maximum point up there. Now, we can go further to discuss the domain of this function as well as the range. Having said this is the minimum point that the graph can go, we say the range is y is greater or equal to -6.25. From here, the graph can go up. But the domain is an x is an element of real numbers. Any number can go there, with a quarter, half, an eighth, 2.5, can go this way, can go that way. Therefore, the domain is real numbers. The domain is the x value, and the range is the y. So the y starts from -6.25 to infinity. That's enough. When you look at a parabola given another equation, which has the turning point and only one point.